Hi all. Someone was pleading to post assignment 3. That's why I'm posting this now at this late night. So, question number 1. Consider relation algebra on these instances. What will be the output? So, let's start from the inner loop. Let's take university and select the tuples where capacity is greater than 2000. So, capacity greater than 2000, we get 3 tuples, first 3 tuples. And from that, project branch and capacity. So we get Bangalore 15,000, Bangalore 40,000 and Jalandhar 5,000. Now intersect it with the another condition. Let's take that one. University project fee with the fees less or equal to 2 lakh. So the tuples will be first tuple will be selected, third tuple will be selected, and fourth and fifth tuple will be selected. The KSSL Bangalore 40,000 5 lakh will be rejected. Now from that, project branch and capacity. So the branch and capacity of only that 4 tuples will be projected. Now intersect these two conditions. When we intersect, the only possible ones will be projected, right? Now when we intersect, the output will be like Bangalore 15,000 and Jalandhar 5,000, because only the what to say tuples that is present in both the condition will be in the output, right? So the answer will be Bangalore 15,000 and Jalandhar 5,000. Now in the left side of this division operation, it is said that project union branch capacity of university. So the whole columns union branch and capacity will be projected. From that, we want to use the division operation on Bangalore 15,000 and Jalandhar 5,000. So what will be the output? It is like if in the right side we have two values, Bangalore 15,000 and Jalandhar 5,000, and both of them is having the same value in the left side, that is in the U name, then that value will be projected. Means this branch and capacity is a subset of U name branch and capacity, right? So the Bangalore 15,000 and Jalandhar 5,000 should have the same value in U name. If it is so, then project that value. Here we can see JFTT is common for Bangalore 15,000 and Jalandhar 5,000. So JFTT will be the output. So option is A. Now let's move to question number 2. Here many of them have some doubt because we have two tables, dishes and dips, but we are not using dishes here. Only the operation is in dips table. So how many tuples are returned in the following relational algebra? That's the question. So start from the inner bracket, that is dips. Now here we use rename operation. From renaming doesn't make any changes in the original table. It is just doing some changes in view operation. So take dips and rename it into dips 1. We are viewing dips into a different section, and it is named as dips 1. From that dips 1, we select tuples where dips dot rating is less than 5 or dips 1 dot price is less or equal to 80. Such a tuple that exists in dips 1 is only salsa 84. So that only one tuple will be selected. Now join that only tuple with dips. Joining dips and that only tuple gives only salsa 84 itself, right? Because the joining condition is done with any one similar operation. What to say? Uh, the same attribute only. Now we have only one tuple, so the output will be that tuple itself. Now intersecting that tuple with dips will give the same tuple itself. Intersecting means only the tuple that contain in both the left and right side will be the output. So salsa 84 will be the output, and from that project dips dot name, that means salsa will be the output. So how many tuples are returned? Only one, right? So option is A. Now question number 3. This one you should know the syntax and semantics. It is taught in lectures. As you can see, lecture slides 12.26 and 12.28. You can see this this syntax and semantics that you one should study. uh, Here we have tuple relational calculus. So that means here, what I don't know what is the name for this special symbol. So before this special symbol there should be a value called t. That is the syntax for tuple relational calculus. So C or D can be the answer, right? So then the selection is done as display all sensor IDs associated with base station ID is equal to PS1. So there exists some S such that in the sensor is the table. So such a selection exists in the sensor where tuples sensor ID should be equal to uh, the selections sensor ID. So the option will be D. The sensor ID, T of sensor ID should be equal to S of sensor ID. That is the basic syntax for tuple relational calculus. And now the other condition is base station ID should be BS1 and S of base station ID is equal to BS1. That's why option D is selected. Moving on to the next question. This is also a similar question, but here we use domain relational calculus. For domain relational calculus, we can see such a operation, such a symbol like greater or equal to sign, and in between we write the attribute value. Here sensor is having 4 attributes: sensor ID, battery, base station ID and range. We are giving some values for these 4 attributes, that is C, D, I and S. In the question they are saying select range from sensor. So what is the value of range here? Range is S, right? So select range means select S. That is why we use S here. And now select S from the sensor. Now we want to write the other attributes, that is C, D and I. So for some C, D and I such that the tuple, the whole tuple should be in the selection. So C, D, I and S should be inside. So it should be in same order also. So here C, D, I, S is present, but in option C we don't have S. And that's the basic syntax that I can't teach you. You should study from the slides. is shown in slides 12.26 to 12.28, and that's why answer is B. Now question number 5. This also they follow some syntax and semantics. For here we use cursor, and after that we don't use as, we always use for. So the option will be B or D. Now the other problem is we don't have this AND operation in SQL. We only write AND A and D. That's why option D is the right answer. These are the basics I can't teach you, right? So I'm moving on to next question. Which of the following schema correctly represent the report's entity set? Here we are saying the reports is uh, the schema, and the reports are also associated with corresponding data and length. Moreover, each report can be written by multiple authors. That's the thing. When we have a multi-valued attribute, it can be written as a separate one. So we can write as reports heading. Heading is marked as underlined because it is the primary key, and heading comma date comma length. Then we want to write another one because authors is multiple, so we write reports one heading comma authors, and heading comma authors altogether we should underline it, then only it will be correct. Option C can't be right because heading date and length is underlined. It is not possible, only heading should be underlined in the first set. So option D is the right answer. Question number 7. Which of the following is true? The schema for device entity will be device model ID color, device sensor model ID sensor name. No, it can't be right. Even if sensor name is multivalued, we represent sensor name as multivalued by giving this curly braces. So sensor name is multivalued, but this is the not the right answer, because if we write like this, model ID and sensor name together should be underlined. Here it is not underlined, so option A is not correct. What about option B? Schema for Devona will be Devona model ID OID. Devona is a relation. A relation can be written as schema by giving the primary key of the two entities to which it is connected. So option B is the right answer. The other one is owner will be OID model ID. No, model ID is underlined. We can't underline model ID because OID is the only primary key. Now option D also, device sensor comma color. Yeah, color is not underlined, and also in the device model ID is only given. No, a color should be given after model ID. So option D is also not right. In question number 8, which of these are true? Participation of college in university is total. We can't say that. We only say entity's participation in a relationship, not the entity's participation in another entity. We can say that a college participation in relationship enrolled. We can't say college's participation in another entity named university. So option A can't be the right answer. What about option B? Participation of college in enrolled is total. Yeah, college in enrolled is total. How is total marked? By double line. The college has total participation in the relationship enrolled. So option B is right answer. moving on to question number 9. It shows which of the following are false. Let's look into the option A. Schema of university is university uname underlined and comma area and location. That is correct. You all know that it is the basic way how to write a schema, and so it is true. We can't give it as read the question properly, because here it is asked false. So option A can't be the answer. What about option B? Schema of university is university uname area location department and employees. It can't be written like that, because department and employees comes under technical, and technical depends on university, so we can write departments and employees in this section. So option B is wrong. So so B can be the answer because it is false. And what about C? Technical can be written as technical uname comma departments comma employees. That is right, because um, technical depends on university. So when we write the schema, we can include the primary key of the in the entity to which it is dependent. So C is true, so it can't be the answer. What about option D? In net, technical are converted as technical 1 and technical 2. It can be written like that because departments and employees are not multi-valued attributes. So option B and D are the right answer. Now moving on to question 10. What will the following relational algebra expression return to the organization? Let's start from the inner bracket. Render join rending. Render comma rending. We have the common attribute render ID. So the table will be like render ID, contact, and car number. From that project, car number only. So we get the uh, whole car number, the complete column of car number, which in which the render ID is same as the rending in the rending and the render. So it is minus from the car projected as car number. From the car number is projected, and from that the second one is minus, right? So what will be the right answer? The car number of those cars that are rendered by at most one render. No, because we already joined render and rending, so we got all the cars who is already given for rending. So we get the answer which is not the cars which did not go for rent, right? So the answer will be D. The car number of those cars that are not rendered by any render, because from the right side projection we got the car number of all the cars who someone rendered, and we are minusing it from the other car numbers. So the other car numbers are the cars which are not rendered by anyone. Therefore option D is the right answer.